January 19th, 2026. Sometime in the darkness before dawn, Black Diamond Pool erupts. The explosion is detected by infrasound sensors and seismometers positioned around Biscuit Basin. Camera views are obscured by ice and the absence of light, but the instruments capture everything: the sudden pressure release, the blast of superheated water and debris. Another violent eruption from the same pool shocked tourists and destroyed a boardwalk just 6 months earlier. 5 days later, on January 24, 2026, it happens again. The Yellowstone Volcano Observatory confirms both events in its February update. At least 2 small eruptions from Black Diamond Pool. Detected but not witnessed. Recorded but not predicted. The hydrothermal system beneath one of America's most visited national parks continues to demonstrate exactly how unpredictable it can be. But the explosions at Biscuit Basin are not the only thing concerning scientists this winter. Ground uplift that began in July 2025 near the north rim of the caldera continues into 2026. GPS stations detect subtle but persistent swelling of the Earth south of Norris Geyser Basin. In November 2025, a swarm of earthquakes struck directly on top of that uplift center. Seismicity and deformation occurred at the same place, at the same time. And beneath all of this activity lies a discovery that has fundamentally changed how scientists understand Yellowstone. 86,276 earthquakes, hidden for 15 years, missed by conventional monitoring, revealed only when researchers applied artificial intelligence to analyze historical seismic data. 10 times more earthquakes than anyone had previously recorded, more than half of them occurring in swarms. Patterns of underground activity are far more complex and far more active than scientists had ever understood. The supervolcano beneath Yellowstone is not sleeping. It is restless. And now, for the first time, we can see just how restless it has been all along. To understand why 86,000 hidden earthquakes matter, you first have to understand what lies beneath Yellowstone. The park sits on top of one of the largest active volcanic systems on Earth. A hotspot where a plume of molten rock rises from deep within the planet's mantle, pushing magma toward the surface. This hotspot has been active for at least 17 million years, leaving a trail of volcanic destruction stretching 750 kilometers across the Snake River Plain. Yellowstone is simply its current location. The caldera measures 45 by 75 kilometers. It formed 631,000 years ago during an eruption so massive that the ground collapsed into the emptied magma chamber, creating a basin large enough to contain most of the national park. That eruption ejected approximately 1,000 cubic kilometers of volcanic material. To put that in perspective, the 1980 Mount St. Helens eruption, which killed 56 people and devastated 600 square kilometers of forest, released just over 1 cubic kilometer. The Yellowstone eruption was 1,000 times larger. And it was not even the biggest one. The first major Yellowstone eruption, 2.1 million years ago, released 2,500 cubic kilometers of material. It created a caldera larger than the state of Rhode Island. Ash from that explosion has been found as far away as Louisiana. 3 cataclysmic eruptions in 2.1 million years, an average interval of roughly 600,000 to 800,000 years between them. The last one occurred 631,000 years ago. Mathematics are not comforting. The newly discovered earthquakes reveal a volcanic system far more dynamic than previous monitoring had suggested. Professor Bing Lee of Western University and his collaborators used machine learning algorithms to reanalyze historical earthquake data from 2008 to 2022. Traditional detection methods rely on trained experts manually inspecting seismic readings. This approach is accurate but slow. It takes time, it costs money, and it inevitably misses smaller events. The AI had no such limitations. It detected earthquakes as small as magnitude 1.5, tremors far too weak to feel but significant enough to map the underground structure of the caldera. By measuring the timing of seismic wave arrivals at monitoring stations positioned around the park, the algorithm could pinpoint each earthquake's location in 3-dimensional space, determining not just where it occurred horizontally, but how deep it was beneath the surface. The result was a catalog of 86,276 earthquakes. More than 67,000 were successfully relocated with precise coordinates. But the number alone is not what concerned the researchers. The pattern concerned them. More than half of those earthquakes occurred in swarms. Earthquake swarms are fundamentally different from typical seismic activity. A normal earthquake produces aftershocks, smaller tremors that follow a main event and gradually diminish over time. Swarms have no main event. They are groups of small, interconnected earthquakes that cluster together in space and time, spreading and shifting within a relatively contained area. At Yellowstone, these swarms reveal something important about what is happening underground. We think much of this activity is triggered by fluids, basically water moving deep in the earth where the earthquakes are happening, explained David Shelley, a seismologist with the United States Geological Survey who collaborated on the study. The researchers found that earthquake swarms beneath the Yellowstone caldera occurred along relatively immature, rougher fault structures. Unlike the mature, smooth faults found in places like Southern California, the faults beneath Yellowstone are fractured and irregular. The study characterized these structures using fractal analysis, measuring how the patterns of seismicity repeat at different scales. The fractal-based models suggest these swarms are caused by a mix of slowly moving underground water and sudden bursts of fluid. Hot water, superheated by magma, migrates through fractured rock, creating earthquakes as it moves and triggering new fractures as pressure builds and releases. This is the plumbing system of a supervolcano, and for the first time, scientists can see how active that system truly is. The AI study was not the only concerning development at Yellowstone in 2025. In July 2025, GPS stations began detecting ground uplift near the north rim of the caldera, south of Norris Geyser Basin. This area had experienced similar uplift between 1996 and 2004. Now it was happening again. Continuous GPS monitoring tracks ground deformation measured in millimeters. The instruments are sensitive enough to detect the subtle breathing of a volcano, the expansion and contraction that occurs as magma and fluids move through underground chambers. The uplift that began in July 2025 was subtle but persistent. By late January 2026, the rate had slowed but not stopped. The ground south of Norris Geyser Basin continues to rise. And directly on top of that uplift center, in November 2025, a swarm of earthquakes struck. This is exactly the kind of correlation that makes volcanologists pay attention. When ground deformation and seismicity occur at the same place and the same time, it suggests a common cause. Fluids accumulating beneath the surface. Pressure building, the system adjusting. The Yellowstone Volcano Observatory emphasized that this activity does not indicate an impending eruption. The alert level remains at normal. The aviation color code remains green. These are the lowest possible designations, but the scientists also noted something important. It is very unlikely to lead to any sort of volcanic eruption. There would be a lot of changes before that would become possible, but it will definitely teach Yellowstone Volcano Observatory scientists new lessons about how Yellowstone works. The volcano is teaching them. The question is what the lessons mean. While the ground was uplifting near Norris, another part of Yellowstone was demonstrating exactly how unpredictable the park's hydrothermal system can be. On July 23, 2024, just before 10 a.m., Black Diamond Pool in Biscuit Basin exploded. The hydrothermal explosion sent steam, boiling water, and debris hundreds of feet into the air. Grapefruit-sized rocks were thrown tens of feet from the pool. A section of boardwalk was destroyed. Trees nearby were killed. Tourists scrambled for safety as the ground beneath one of Yellowstone's thermal features suddenly and violently gave way. The explosion occurred because superheated water beneath the pool suddenly transitioned to steam. Water under pressure can remain liquid at temperatures far above its normal boiling point. When something disrupts that pressure, when a fracture opens or a pathway clears, the water flashes to steam instantaneously. Steam takes up far more space than liquid. The result is an explosion. Hydrothermal explosions occur at Yellowstone 1 to a few times per year. usually in backcountry areas where they go undetected. The July 2024 explosion happened in front of tourists at a popular visitor area just 2 miles from Old Faithful. Since then, Black Diamond Pool has continued erupting. Dirty explosions reaching 30 to 40 feet in height have occurred sporadically from the pool. The Yellowstone Volcano Observatory installed a webcam in May 2025 to monitor the activity. In January 2026, at least 2 more small eruptions were detected by infrasound and seismic monitoring. Biscuit Basin remains closed to visitors. The hydrothermal explosions are not volcanic eruptions. They do not involve magma reaching the surface. But they demonstrate something critical about Yellowstone. The shallow hydrothermal system is constantly changing, constantly unstable, and capable of violent events with no detectable warning. The July 2024 explosion had no precursors. Seismicity, ground deformation, and gas emissions all remained at normal background levels. There was no way to predict it. And there is no way to predict the next one. The question everyone asks about Yellowstone is simple. When will it erupt again? The scientists have a frustrating answer. They do not know. And more importantly, there is no evidence that a major eruption is imminent. The U.S. Geological Survey is clear on this point. Another catastrophic caldera-forming eruption, like the ones that occurred 2.1 million years ago, 1.3 million years ago, and 631,000 years ago, is possible but extremely unlikely in any human timeframe. The most probable future activity would be hydrothermal explosions or lava flows, neither of which would approach the scale of those ancient catastrophes. But the 86,000 hidden earthquakes reveal something that statistics alone cannot capture. The volcano is active, constantly active, more active than monitoring systems had detected for 15 years. Swarms of earthquakes ripple through immature fault zones. Fluids move through fractured rock. Pressure builds and releases in patterns that scientists are only beginning to understand. The AI study provides the most comprehensive look ever assembled at long-term seismic behavior beneath the caldera. It shows that swarms which occurred years apart can strike nearly the same physical location. It reveals that more than half of all seismic activity at Yellowstone occurs in these interconnected clusters rather than isolated events. It demonstrates that the underground plumbing system is dynamic, responsive, and far more complex than simpler monitoring had suggested. We have a far more robust catalog of seismic activity under the Yellowstone caldera, Professor Lee explained. And we can apply statistical methods that help us quantify and find new swarms that we haven't seen before, study them, and see what we can learn from them. The learning has only begun. February 2026. The Yellowstone Volcano Observatory publishes its monthly update. Yellowstone caldera activity remains at background levels. 100 earthquakes were located in January. The largest was magnitude 2.6. Ground deformation measurements indicate continued subtle uplift along the North Caldera Rim, as well as the onset of caldera subsidence in late December. At Biscuit Basin, at least 2 small eruptions occurred at Black Diamond Pool on January 19th and January 24th. They were detected by infrasound and seismic monitoring. Camera views were obscured by darkness and ice at the times of the events. The average tourist visiting Yellowstone sees geysers erupting on schedule. They photograph bison grazing in meadows. They marvel at prismatic hot springs painted in brilliant colors by thermophilic bacteria. They walk on boardwalks that pass over ground heated by magma chambers kilometers below. They do not feel the earthquakes. Magnitude 1.5 tremors are far too small to notice. They do not see the GPS data showing millimeters of ground uplift over months of measurement. They do not know that beneath their feet, swarms of seismic activity are migrating through fracture networks carved by fluids hot enough to flash instantly to steam. But the instruments know. The AI knows. And now, so do the scientists. 86,276 earthquakes in 15 years. More than half occurring in swarms. Ground uplift resuming at the North Caldera Rim. Hydrothermal explosions continuing at Biscuit Basin, a volcanic system that has produced 3 of the largest eruptions in Earth's recent history. showing exactly the kind of restless activity that researchers would expect from a still active supervolcano. The Yellowstone Volcano Observatory will continue monitoring. The AI will continue analyzing. The ground will continue moving in ways that are imperceptible to visitors, but unmistakable to instruments. And the volcano will do what it has done for 17 million years. It will remain active. It will remain unpredictable. It will remain one of the most powerful geological forces on the planet. The question is not whether Yellowstone will erupt again. The question is, what happens when it does?